Hello everyone. Today our topic is window functions partitioning, that is window spec. So it means how to do partition by in window functions. So partition by we can use in two different areas. So one is DataFrameWriter.partitionBy. One more is Window.partitionBy. So that means while writing the data to Delta Lake, so that time we can write use partition by, and at the same time while using window functions, so mainly aggregate functions, we we can use this partition by. So this video is restricted to how to use partition by in window functions. So what is a partition by? So partition by is a method to organize the data into logical groups. So if you omit partition by, Spark is forced to move all the data to single worker node to perform the calculation. So which can lead to out of memory errors on the large data sets. So that means if you remove the partition by and if you mention only order by in aggregate functions, so what will happen? It don't split the data into number of partitions, so that the whole data it will supply to single worker node, any one of the worker node. So since work will get more on this worker node, so sometimes whenever we supply large data sets, it will throw you out of memory error. So first we'll see the difference of partition by using while writing the file and while using the window aggregate functions. So primary goal is while writing the file, so physical storage layout on the disk. So that means so, by doing partition by saving the data into disk with number of partitions, and in window logical grouping for calculations. So to perform aggregate functions, so we'll split into number of groups here. And output, if you see the output, so the folders on the file system. So since we are using partition by, so each partition folder, it will be on the system. So here aggregated or ranked columns in the memory. So what is the impact is speeds up the reads. So that means once you write the files by using partition by, so whenever you read those files again, so the speed will be quick in case of reading the files. So here what happened, it enables complex analytical queries. So based on each partition, we can query, so that queries will get fast. So what is the syntax is, so window.partitionBy. So whenever you use window functions, so window dot two things we need to provide. One is partition by and order by. And and if you see partition by, so partition by on which column. So all this can be always mainly primary keys, and order by we need to provide the column. So based on each partition, so based on which column we need to do order by. And so finally where we'll use this window underscore spec is, so df dot with column. And so here I want to add the rank column. So this can be any of the window aggregate function. So here I given rank. So this can be row number, rank, dense rank, percent rank, and lag lead. So any one of the aggregate function. So dot over and this window spec. So this whole thing we are passing here. And this window we are importing from PySpark.sql.window. So this is the standard syntax we'll follow whenever we are working with window aggregate functions. So first I have one sample data frame. So here I have data. So I have two columns here. So one is category and second one is amount. So by using Spark.create data frame, I created the sample data frame. So this is category and amount. And if you see, this is one group, A, category A, and B. So this is one group, and C, this is one group, and D, this is one group. So on top of sample data frame, what I'm doing, I'm going to apply different aggregate functions. So in this first, I'm applying row number. Okay, I will leave it like this only. So first I'm applying row number. So before that, we'll understand what is these three different ranking functions. So first one is row underscore number. So what it does is it assigns a unique sequential number to each row. Suppose in this group, what it will do, so it will assign rank 1 and rank 2, rank 3, rank 4. So it will assign in sequential order, unique sequential order. And what happens whenever we have tie value? So that means duplicate value. So it will give you different consecutive numbers. So that means it will give 1, 2, 3, 4 like this. Even though if you have tie, it will give consecutive numbers. And if you see the rank, it assigns the same rank to tied values, but leaves a gap in the sequence. So that means, so tied values receive the same rank. Suppose if you see here, here will be rank 1, rank 2, rank 3, and here, since we have tied value, so here it will give you same rank it will give you. And it will give you same rank, and for next record what it will give, subsequent ranks are skipped. So that means if you see here, first record is unique record, second and third are the tied values, and next it coming unique value. So what it doing, so here 2 is there, but it not printing 3 here, it printing 4. How it printing? 1, 2, and 2 is repeating 2 times, 2, 3, then 4. That 4 it printing here. So that means it leaves gaps in the sequence. Suppose if you are getting three continuous uh, 2 as 3 times, like 1, 2, 2, 2, then next consecutive number will be 5. So like that it will print. So next is dense rank. So dense rank also it assigns the same rank to the tied values, but does not leave gaps. So that means for same example, 1 and second and third are the tied value, and for fourth unique value it will give you 3. So that means after 2, 3 it will give you. So this is the overall difference between these three functions, how it will give ranking. So now first we'll apply row number function. So what is the syntax? First window.partitionBy. So I'm doing partition by on category, this category column, and I'm doing order by on amount. So what will happen? So it will divide this partition by, it will divide into categories. So first category is this one. A is a category. Next, since we given order by, so order by, and after that we are not mentioned descending. So since we are not mentioned descending, so PySpark by default it is ascending. So if you mention or not mention, by default it will take ascending. So the amount values it printing in ascending order. If you see the input, so here 100, 200, 300, 300. So here we have in order, but whenever you have different order, then we'll see the difference. So what I will do, I will try to change the order instead of this. What I will do, so we have in sequence, right? So what I will do, I will change this one. So here 300 and this 200, let it be here 300. Here I will give one more value, maybe 400. Okay, so now we'll see the difference. See here in this category, how initially it is 100, 300, 200, 300, 400. So that means it is not in either ascending order, descending order. But whenever you see here, after applying order by, so it coming in order. If I update this one, so you can see updated uh, group here up to here. See here, now it is coming in ascending order. So 100, 200, 300, 300, 400. So now how this ranking it gives is, so it always give consecutive numbers. So whether it is unique value or duplicate value. So suppose if you see here 300, 300 is there. So, but still it is giving consecutive number. So here what I will do, I will try to add one null value also here. So now my category is with null value also. So now what I will do, I will try to rerun my next cell and we'll see the difference what happens. See here in ranking, null always it considered as the small value, so it come at the top. So rank will be 1. And see according to that, this ranking also will adjust. See here 1, 2, 3, 4, 5, 6. So next we'll see one more group. So here B. So initially we see how the order it is 50, 70, 90. So here what I will do, here also I will add one null value. Maybe in between I will add. And maybe I will change these values. Here I will give 70. Uh, Here I'll give 90. And here I will give 50. So now we'll see the difference. See here, now it is in either in ascending order or descending order. So if I update this one now, you will get this B group in ascending order. See, first will be null, then all the values in ascending order. And according to that, you will get consecutive numbers here. So next, if you see C group, so here also you can try with adding null values here. You can try with adding null values and you can change the order. So according that you will get ranking, and this D group also same thing. You can add some null value and you can rearrange the row so that you will get in ascending order. So ranking will be 1, 2, 3, 4, 5. So next what I'm doing, Window.partition by category, and here what I'm doing, descending I'm mentioning. So earlier I'm not mentioned anything here, just simply order by amount. So here order by descending. So descending amount. So earlier case, without considering, means without mentioning anything, Spark will consider by default ascending order. Now, since I mentioned descending, so it will show the value in descending order. So that means higher to lowest. So if you see the first category, so first is the highest value, that is 400, next 300, 300, 200, 100, and null value. Null value is the lowest. So, and if you see, according to that, the ranking will be given in consecutive numbers. And same for group B also. If you see higher to lower values, and ranking will be here 1, 2, 3, 4, 5 consecutive numbers. And same way we'll see for rank function. So here what is the difference in syntax? So only function is changed. Instead of row number, I given row. If you see row number, and one more difference, here I mentioned descending. So here I'm not going to show with ascending and descending, directly showing with descending. So with my initial data frame, if you see here, so ascending means rank function, how it works. Since it is printing from higher to lower, so here it is tied records. So for both it giving 1, 1. And for next record, what it giving 3. Why it giving 3? Here this is 1, this is 2, and whatever gap is there, it not printing. So next consecutive number it printing. So next it is 4, and next this is other group. And if you see in this, 90 is the unique value and 70 is the tied value. So we are getting 2, 2, and for next value we are getting 4. That means that gap it removing. So next consecutive number we are getting. This is up to here. Same way for C group also. So rank 1, rank 2, and here we have tied values. So that is 3, 3. And similar way for group 4 also, group D also. So here tied value 1, 1, and for next value it will give you 3, and 4, 5. So now what I will do, I will update this one. So it will update as per latest updated data frame. See here, what is our updated data frame? So I changed the order in my data frame and I added one null value. So since it is a descending order, so higher to lower, so null is coming at the end, and so from higher to lower it is coming. So first unique value is 1, and second we have tied values 300, 300. So after 1, 2, 2 we are getting 2, 2 times, and for next value we'll get 4. And here what I will do, I will add one more duplicate value here. Here maybe after this I will add one more duplicate value. I will add, that is with 300. So now we'll see the difference. When you have 3 duplicate values, what will happen? So row number, it is same. So whether you have 2 duplicate value or 3 duplicate value, it will give you consecutive numbers. At the same time, here also by using descending also same. And if you come to rank, so here we have 2 tie values. So here we have 2, 2. So now what I did, I added one more tied value. So here we'll get 3 tied values. So after 1, we are getting 3 2s. And what is the next consecutive number? 5. So earlier 4 is there. So how it coming 5? So here it is 1, this is 2. So within 2, 3, 4, 5. So if I add one more 300 here, then here it will print 6. Why? Because here 4 common records will come. So 5, 6, 7. Okay, so that's how the rank will print the ranking. So next we'll come to dense rank. So here I'm using descending, and instead of rank, I'm using here dense rank. So with the old data frame, we'll see first. So this is my first category. So my first two values are tied values. So it gives you same ranking 1, 1. And for next record, what it printing 2. So it is not like rank. So 1, 2, and skipping the rank and giving, not like that. So it will give you next consecutive number only. So whether it is 2 times tied or 4 times tied, so next rank will be next consecutive number, and next 3. And similar way for this group also. So first one is 1, next 70 is there. So 2 tied records, so that is 2, 2, and the next record is 3. After 2, 3. So now what I will do, I will update this one. So we'll get latest updated records. Now, if you see our latest records, so this is the group. So in this 400 is unique number. So 1 we will get. And next we have 3 tied records. So after 1, so these 2 will get 3 times, and for next this one you'll get 3. So means after 2, consecutive number is 3, 3, 4, 5. So whether this is 2 tied values or 100 tied values, so next rank will be 3 only. Okay, so same thing will apply for here also. So rank 1, and here tied is 2. So 2, 2 is there. So next it will come 3 and 4. And for remaining groups also same. So now we discussed 3 functions, ranking functions. So now we'll see about max function. So when you apply max function in this, what will happen, we'll see here. So here what I'm doing, maximum value I'm taking per group, but without aggregation. So without aggregation means, so Window.partitionBy. So I'm doing partition by category, and here I'm not mentioned order by. So since I'm not mentioned order by, so what will happen? Window.partitionBy means this, it will do the grouping. So this is the first group up to here. This is the first group. Next, after doing group by, what I given with column max underscore amount. So this new column. So in this, what it will do, since I given max of amount, so that means in this, so in this, what will happen in this particular group, it will find the maximum value. So here we have 300. 2 times it is there, but still it is maximum value. So that maximum value, it will print in entire window. And same way for group B also. So in this, maximum value is 90. So it will print entire window. And at the same way for C also. So here maximum value is 100, and it will print uh, for entire window. So now what I will do, I will update this one so that our latest records will come. So now it will change little bit. Why? Because so here I added one null value, and if you see here, since I'm not mentioned order by, right? So earlier if you see, same as it is, it came. means how I given input, same as it is I given. So in earlier input data frame, what I given, this amount values I given in ascending order, like increasing order, 100, 200, 300, like that. So now what I did, I purposely rearrange the data like mixed way. That means either it is not in ascending order, either not in descending order. So what happening, since I'm not mentioned any order by here, order by part itself, I excluded here. So same how my input sample data frame is there, same way the values are getting. Okay, so 100, 300, 200, 300, 400, 300. So same way it is getting. So it not changing the order. So, but still it will find the maximum value from this. So maximum value is 400 and it printing the 400 entire window. So here what I will do, I will try to add one more, I will try to add one more column here with minimum value and we'll see what is the result. So I will print this one. So now minimum minimum amount. Okay, here I'm not changed. So if I print this one and you see from this group, it ignoring null and minimum value is 100. So that 100 it printing the entire row. Okay, so same way for other window also. If you see this particular window, so in this maximum value is 90. So for 90, it will print here for entire window and minimum value is 50. So in minimum column, it will print entire group as 50. And similar way for C also. So here maximum value is 100. So it will print 100 for entire window and here minimum value is 50, so it will print entire window. So similar way for this particular group, maximum value is 85, so 85 it will print entire window and 20 it will print entire window. Okay, so next average value per partition. So here also I'm not using order by. So what I changed here is instead of sum I given average. So with our old sample data frame, see here old sample data frame, since I given in ascending order, it coming like this as per sample data frame 100, 200, 300. So if I update this one now, we'll see it will come as per latest sample data frame. See here in same order it will come 100, 300, 200, 300, 400 like this. But what it does, this average function is from this window, it will add all the values. It will do sum of all the values and divide by 7. And whatever average value it coming, it will print for entire window. And if you see, if you observe, so here null also, for null also, it printing the window. But we'll just calculate once how it taking. Uh, Calculator, just 1 minute. Okay, so here we'll do calculation. So first, what is there? 100. Next, 300. Next, what is there? 200. Next, what is there? 300. Next, 400. Next, 300. Okay, so I will add this and 1600. What I will do? First, I will divide by 7. So I will see what value will get. So 228. So it not taking average of null values, it taking only 6 values. So 1600, 1600 divided by 6. Okay. So what it happening? So even though here null is there, so but it taking average of only this 6 rows. So these 6 rows average value it taking, and that average value it printing even for null windows, null row. Since it is null value, it is in our window, so it printing for null row also. So same thing here also. If you see window B, so what we have 70, 70, 140, 140, 190, 190 plus 90, 280, 280 by 4. So 280 by 4 will get 70. Okay, so similar way it will calculate for all the values. So this is about average function. So next we'll come to lag and lead. How to apply partition by in case of lag and lead aggregate functions. So first we'll see lag. So what is lag is it will print previous row in the same group. So what is the syntax is lag, and inside that we need to pass the column name. So for which column we need to apply lag, and by default offset is 1 and this default is none. So the default value is none. The default value is 1. That means this one, the immediate previous row. So for every row, it looks back the specified number of rows within the same bucket. The first row of every partition will always return the default value or null because there is no previous row to look at within that partition. So this will see what it meaning. So here what I'm doing, partition by category, order by amount, and here uh, actually this is one line of code. So with column, and my column name is this one. So instead of here, earlier we used to row number, rank, dense rank, max, min, average. So here I'm using lag function. And what is the syntax for lag? We need to pass the column name inside, and we need to pass the this number offset value. So it is fine to write offset equal to 1 or simply 1. So here I'm trying with different numbers here. So first I'm trying with offset equal to 1, and second I'm trying with offset equal to 2. So first we'll see these two lines of code, what it means. So our first input is this one. And since it is doing partition by on category column, so what I will do, I will update this one so that latest data frame will reflect here. So this is my first category. This is my first category. So here I given order by. So by default it considers ascending order. So it printing in ascending order. So small value to big value. So now first I'm trying with lag with offset 1. Lag with offset 1. So what it means is, so here for this particular value, we don't have previous value. So what here it telling, the first row of every partition will always return the default value or null value, because there is no previous row to look at within that partition. So that means within that partition, previous value means here. Before this value, we don't have any value. So it will print as it is. Same null value, it will print here. Next, for this value, what is the previous value? That is null. So it printing here null. And next come to here, this one 200. Previous value is 100. So that it printing here. For 300, previous is 200. That it printing here. For 300, what is previous value? This one. For 300, what is previous value? 300. And for 400, what is previous value? 300. And for null, okay, so our window is up to here only. So this how it will work with offset 1. So next line of code, what is there? This is offset 2 with offset 2. So with offset 2 means since we don't have previous value, it will print null. Same value, it will print. So next for 100, earlier I given offset 1. So what 1 means it will look previous value and it printed here. But here, since I given offset as 2, so it will look for second value. From here, second value it will look. Since we don't have second value, two values, we have only one value. So it will print null. And if you come to 200, offset 2. So offset 2 means second value. So we have null. So we are getting null. And for 300, what is the offset to 100? This 100 it printing here. And for this 300, what is the second offset? 200. That 200 we are getting. And for this 300, what is the second offset? This 300. So that it printing here. And for this 400, what is the second offset? 300. That it printing here. Okay, so this how it will print. And one more thing, this one null is there, no? So I think I told mistake, like, so for null value, it will look for second offset value. Since already null is there, so here don't get confused. Suppose in case here we have 0, still you'll get null only here. Why? Because this value, it will look for second offset. So since we don't have second offset, we'll get null only. So same thing applies for other windows also. And next we'll see what is this third line of code. So this is offset value, 2 is offset value, and here 0. So what is this 0 is? Here default it is none. So default it is none means, so here wherever value is not there, so it printing nulls. So now I don't want to print nulls. I want to print some other values like either 0 or -1 I want to print. So what will happen if you see in this particular row, I given 0. So wherever null is there, it will come 0. So that means if you see this particular case, here what happening, this is 2 offset, right? So this is 2 offset. So for first value, since we don't have second offset, so it printing 0. So as I told here, it printing null, not because of here null is there. Since we don't have second offset here, it printing null. So now I defined, I don't want null, I want to print 0. So I'm getting 0 here. At the same time, -1. And if you come to this value, for this value, second offset, I don't have. So here it print null, but in this case, here it will print 0, here -1. So any value you can give. I given here 0, -1, you can give any other value. And next, if you come to 200, so what is second offset? Null. So that is the reason we are getting null here, here and here. And if you come to 300, what is second offset? 100. So 100. So that 100 we are getting. And for this, what is second offset? 200. So we are getting 200 here, here. So remaining is same. And same way it applicable for other windows also. So here also same only. So this is about lag function. So we need to remember the syntax and we need to understand what is this offset. Offset 1, 2, or we can give some other number also. I tried with 1, 2. Maybe you can try with 3, 4 also. So it will work. Working will be same. And we need to remember about this third argument also. What is this third argument? So this is about lag function. So next we'll look into lead function. So lead function, what is the syntax is? Offset is optional. So number of rows to look forward. So default is 1. So lag also default is 1. And in lag, what it does, it will look back. That means it will look previous record. But lead, we need to look forward. Suppose if you are giving lead and column name and number we are giving 1. So that means offset value we are giving 1. So that means it looks one row ahead and it returns none if no next rows exist. So earlier case what happened? It will look uh, previous record. If there is no record, it will print none value. So here it is opposite. It look forward, and if there is no record, then it returns none. So if you give 1, it will look one row ahead. If you give 2 here, that means offset 2, it will look 2 rows ahead. So that is a difference. And here we'll see one more difference. What is lead and lag? So lead, what will happen? Future. That means it will look forward. And lag means past. It will look backward. So lead will use for calculating the time until the next event or the next price change. So calculating the difference from the previous value. So that is month over month growth. So now we'll see about lead function. So same syntax I took. So working will be same. So instead of lag, I given lead. If I try to update this one, you'll get with the latest records. And if you see this first group up to here, this is our first group and first column, how it will print. So for first value, in this case, it will look one row forward, one row forward. So what is one row forward? 100. So first it will print 100. Next for 100, it will look one row forward. So that is 200 it will print. Next for 200, one row ahead 300. So that it will print here. For 300, one row ahead 300. It will print 300. And here, what is one row ahead? 300. That is 300. And here, one row ahead 400. That is 400. For 400, one row ahead, we don't have anything in this group. If you see here, for 400, we don't have anything here. So we'll get null value. So now you understand the difference, like in lead function, we will get null value at the end. And for lag function, we will get null value at the starting. And next one is, this is offset 2. So this is offset 1. And if you see here, this is offset 1 and second is offset 2. So here what happens? For first value, it will look second row. From here, second row forward. So that means for null, 200 is the value. So it printing 200. And next for 100, 300 is the value. Next for 200, 300 is the value, and for 300, this 300 is the value, and for this 300, this 400 is the value, and for this 300, and if you see second offset, we don't have in this group, so it will print null. And for 400, we don't have second offset here, it will print null. And here what happens, same way it will work like this. This working of result will be same. So only difference is, since I mentioned default value as 0, so wherever nulls we are getting, we'll get 0. For this column, we'll get 0. For this column, we'll get -1. So that is the difference. So now you understand clearly what is lag and lead functions and how it works. So next we'll see what is running total partition. So that means calculating the sum within each group. That means each partition row by row. So in this mainly we are going to use these two window functions. So one is Window.unboundedPreceding. So under window, we have this function unbounded preceding. So normally how we are passing here Window.partitionBy. So same way we have Window.unboundedPreceding and Window.currentRow. So what this function does is unbounded preceding start from the very first row of the window or partition. Start from the very first row of the window, and Window.currentRow is up to current row. So what it meaning is, take all the rows from the beginning of the partition up to this row. So these two functions I'm using here. So Window.partitionBy and orderBy, and additionally I'm giving this one. So Window.unboundedPreceding and Window.currentRow. So these two functions I'm using by rowsBetween. So that means I want to find the rows between these two range. These two range means starting first row of the window and current row. So between these two, I want to find out the rows between. And this whole thing I'm passing into over function. And what is my aggregate function here is sum. So I want to find out the sum value. So cumulative sum I want to find. So now what will happen? So this is my first group. Maybe I'll update this one so that latest record will come. So this is my first group up to here. So here how it works is, so for null, it will come null. And for first 100, so we'll get 100 because null plus 100, it is 100. Next, if you come to 200, so 200 plus 100, we'll get 300. So next, this value 300 plus 300, we'll get 600. And this 300 plus 600, we'll get 900. And this 300 plus 900, 1200. And 400 plus 1200, we'll get 1600. So like this, we'll get cumulative sum of this column, that particular group. So we'll see how it works actually. First row, we have 100. Okay, so I need to update this one. So that is fine. So first row is 100. So null, you forget it, we are getting null only. And for second row, that is 100. So 100 plus null will get 100. And for 200, so this 100 plus this 200, we are getting 300. And for third row, for this 300, this 100 plus 200, that means 100 plus 200 plus this 300, total 600. So why we are getting here? We are mentioned that Window.unboundedPreceding. That means start from the very first row of the partition. Start from the very first row of the partition. So that means whenever you adding up, whenever you are going next row, see here, this is first row, we are getting as it is. For second row, 200 is there. So what it meaning rows between this whole thing. So it considering from first partition. So this is the first partition value of the window, that is 100 plus until current row, that means 200. So plus 200, that we are getting 300, sum of these two values. And when you come to here, since it is starting of the partition, that is 100, next is 200, next partition value, and current value is 300. So total 600. And next, if you come to this value, so our first value is 100 that we are getting here. And next, what is next value? That is 200 that we are getting here. Next value 300. Next value 300. Total 900 we are getting. And at the same way, we can do for other row also. Like this is 5. And what is other value? 2, 304. Next we have one more 300. So this also 300. So what will happen? First 100 is this one, and next 200, next 300, next 300. We need to add one more 300. So why? Because as per that condition, from first value of the partition to current row of the partition. So what will happen? 1200 will get. So 900, 1200 will get. So next we have one more value, that is 400. So this is 6 and this is 400. And we need to add here 400. If you add 400 to 1200, you will get 1600. Okay, so this how it will add the values. If you see at the end value for a end row, what is happening from 100 to 1 by 1, it adding. So that is cumulative. So that is the meaning of first one, unbounded. Window dot unbounded preceding is this one. So first value of the partition, and window dot current row is this one. And on top of that, we given rows between. So it will consider all the rows. And finally, we given sum up. So it will do sum up of from this row to this row. So that's how we are getting cumulative. So same explanation I given here. So row 1 start to current. So start to current is 100. So initially we have only 100. And for row 2, starting is 100. And that means this starting is 100. And for second row, what is current value? 200. That is this one. And for third row, starting value is 100. Starting value is this 100. And what is the current value? 300. So that means it will take all these three values, 100, 200, 300. And you can update this one up to here. And what is the summary is, so common window functions. The common window functions we use while doing partition by, or you can say common window functions. So one is row number that we saw. So whether this one needs order by, yes. And rank, dense rank, these three required order by. And running total, while running total sum. So here we saw, so order by is required. And next, max and minimum function, we saw that we are not used order by. So order by is not required for max and min, and for average also. And next, lag and lead, that is required. Order by is required. and count per partition. No, because we are just want to count the number of rows per partition. So ordering is not required. And since we are doing average means just summing up the values and taking divide by number of rows. So here ordering also not required. And for finding the maximum value and minimum value also ordering also not required. So this is the summary. So this is the detailed video on how to apply partition by in all the aggregate window functions. So that's all about this video. If you really like this video, please like and subscribe. Thank you.